Now we are going to deviate a little from the trick and learn some math that will be helpful for mastering the trick. Ternary numbers. Okay, so you know the numbers we used are called decimal or base 10. They come in chunks of 10, so to speak. We have 10 symbols or digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and we combine them to form bigger numbers. When we combine them, place value comes into play. The leftmost digit represents the ones. Next we have tens, then hundreds, and so on. The digit in the tens column is worth 10 times its value. The number in the hundreds column is worth 100 times its value. Then thousands are worth 1000, etc. But wait, where do the 100, 1000, and the rest come from? Well, 100 comes from 10 times 10. 1000 comes from 10 times 10 times 10, and so on. Each time you add another 10 factor to the multiplication. Okay, so you already knew that. What you might have not known is that just as we use this 10 base system, we could have a number system with any base. For example, if we only used zeros and ones, we could build a binary or base 2 number system. This is actually heavily used in computers and barcodes. The Mayans used a base 20 system. Yet another example is a ternary system, the one we need for the trick. Ternary means base 3. So we use 3 digits, 0, 1, and 2. Now let's figure out this system's place value. All we need to do is change all 10s for 3s. The leftmost position is still going to be the ones, just like before. The digit in the next position is worth 3 times its value. Next position has a value of 3 times 3, and so on. So for example, in the ternary number 102, the 2 is just a 2. The 0 has a value times 3, but that is still 0, and the 1 has a value times 9. So 102 is the same as 9 plus 0 plus 2, which is 11. This means the 11 in decimal form represents the same quantity as the 102 in ternary form. You can find a ternary representation of your favorite number. For example, what would be the ternary representation of 23? To find out, we need to split our number into chunks of 1, 3, 9, 27, etc., our place value numbers, and try to use the biggest ones when possible. 23 is smaller than 27, so no chunks of that size. How many groups of 9 go into 23? 2. How many groups of 3? Only 1. 2 chunks of 3 would take us beyond 23, and since we are at 21, we only need 2 more groups of 1. So our usual number 23 in base 10 is the same as 212 in base 3. This task is about practicing ternary numbers. Figure out the ternary representation of the numbers 0 through 26. Post your results here. You can type them or upload a picture of your work.